All right, watch and listen carefully here, guys. Okay, for question number 1, for part A, does direction matter? But does it for part B? It does. Okay, velocity is a vector quantity. If I want to find average velocity, I need displacement over time, and displacement is vector, so direction matters for that part. Distance is scalar, so it doesn't matter whether I'm going north or south for part A. Okay, and that's the importance of this quiz, is to illustrate how important it is to know which are vector quantities and which ones are scalar quantities. All right, so marks will go as follows. If they have givens written down in some form, give them a mark. Okay, that would include that the displacement in part 1 is 2,500 meters north, and the time is 75 seconds. Okay, and for part 2, 18 meters per second south in 55 seconds. All right, in part 1, they already give me D and T, so I don't have to do anything with part 1. It's already essentially got everything I need. Part 2, however, does not have everything I need because it does not give me displacement. Thus, I have to calculate it. All right, I calculate it by manipulating V equals D over T to solve for D by multiplying both sides by T. So T times V equals D. So that's what we have here. All right, that's 18 seconds times 18 meters per second times 55 seconds. And that gives us 990 meters south. Give them a mark. This is a method mark. As long as they have velocity times time, give them a mark. That's a method mark only. Okay? If they didn't get the 990, well, that'll get them later. Okay? As long as they knew that that's what they had to do, they get that mark. All right. Now that I have how far it traveled in both parts, if I want to calculate distance, all I have to do is what with this number and this number? Nope. I don't subtract. I add, because direction doesn't matter for distance. Distance is scalar. It just wants to know how far I went. So for part A, here's their next mark. 2,500 plus 990 is 3,490 meters. One mark for 3,490 meters. Okay, for part B, their first mark for part B is for calculating total displacement over total time. So that means 2,500 meters north plus negative or minus, however they did it is mathematically the same, okay, 990 meters. All right, they have to indicate that this was in a different direction than this one. All right, so they get a mark if they have some kind of setup like this. Maybe they did those separately and they have 4,610. 4,610, where did I get that number from? Wow. That's just terrible. Anyway, okay, maybe they just got what this adds up to over what this adds up to, which is 1,510, not 1,410, okay, 4,610. 1,510, okay, over 130, okay, so give them a mark. That's method mark there. As long as they showed that they went total displacement over total time, give them that mark. The proper answer is 11.6 meters per second north. They must have the north and meters per second to get that mark. If they're missing either one, they don't get that mark. Okay, there's no half marks. They either have the right answer, which includes everything, or they don't. Okay, everybody understand how that question worked now? Okay. For question number 2, similar thing. Okay, if you're running line drills, or as we like to call them, suicides, because afterwards you want to. Okay, if you're running them properly. Basketball player runs 15 meters at 10 meters per second, then runs backwards 10 meters for 1.1 seconds, and then runs forward 15 meters in 1.6 seconds. We want the average speed of the player. So I give you forward, backward, forward, and then I ask for a scalar quantity in which the direction does not matter. Yes, I know that's mean. Okay? But again, the purpose of this quiz is to illustrate how important it is to know whether you need direction, even if it's given to you, because that happens all the time. All right? So, if I want to find average speed, I need two things. I need total distance and total time. All right, so give them a mark if they have their givens written down. We were told how far they went in part 1 and what speed they ran at. In part 2, we were told how far they run and how long it took, and same thing in part 3. Okay, next mark will be for manipulation of v equals d over t to get the time for part 1, because we weren't told that. All right, so the manipulation is t equals d over v. Give them a mark for that. Okay, and it should come out to 1.5 seconds. Give them a mark for that. All right, so we're up to 3 out of 5 marks here. Okay, the fourth mark is for showing that speed is total distance, 15 plus 10 plus 15, because direction doesn't matter, okay, over the total time, 1.5 plus 1.1 plus 1.6, or maybe they just had 40 over 4.2. That's fine too. Give them a mark if they showed, okay, that method mark there. Answer comes out to 9.52 meters per second. All right, if they just have 9.5, that's fine. Okay, but they have to have the meters per second. If they don't have that, it's wrong. Okay? If they put a direction on there, it's wrong, because speed is a scalar quantity. It cannot have direction. All right, questions on how that one works? All right, I believe it was out of 10, right? Yeah, it's out of 10. Give them a mark out of 10. Let them see it. Put it in the box. Emma, question? Okay, so when you first get to Google, okay, you're going to click on the little squares up here, okay, and you want to go to Drive. Okay, and you'll either have the old drive or the new drive. If you have the old drive, it'll say, take me to new drive. Click on that, and then it'll look like this. Okay, if not, you'll have a create button up here instead. Okay, but you might as well use the new drive. It really isn't any different. All right, so we're going to click on new. And when we click on that, it's going to have some options here. Okay, Google Docs, Google Slides, Google Sheets. We want Google Sheets because we're going to make a spreadsheet and then use that spreadsheet to make a graph. Okay, so we click on that and it'll open up an untitled spreadsheet for us. Okay, now we can call that whatever we want. Okay, I don't know, we'll just call it book thickness graph because that's what we're going to be graphing. Okay, so here's where we're at. Okay, now we've got all of this stuff, and I'm just going to make it so that I can see both things at the same time here. Everyone to this point with me? Okay, I will wait 1 second here for you to all get caught up. Okay, so follow along with me here, guys. Okay, what we want to do is whatever we want on the x-axis, okay, we need to put in the first column. All right, so we've already decided that for this one, our number of sheets was going to be our manipulated variable. All right, so that's going to go in our first column here. Okay, so if I click on that, I'm just going to put in number of sheets. Okay, and the units for that can be sheets, because that's really the units for it. All right, and I'll just make that a little bit wider. Whoop. Just so that it all fits and doesn't disappear. Okay, and then here for my y-axis, my responding variable is going to be the thickness of the book. Okay, and that's going to be in millimeters. All right, that way I don't have to put units in each square because Google Sheets doesn't like that. Okay, if you actually put letters in with numbers, it gets very confused and won't graph anything. Okay, so you put the units up at the top. All right, now I'm going to put in my numbers. So the number of sheets starts with 20, okay, and then 30, and then 40, and then 50, and sometimes you can even do this down to 80. No, didn't do it right. Okay, sometimes it works, sometimes it doesn't. Okay, so we got 40, 50. Oh, I know why, because there wasn't a good pattern for it to recognize. Okay, 60, 80, and 100. All right, so we've got the numbers in for number of sheets, and then we'll put in the ones for thickness of the book. So 8, 9.5, 11. You don't have to put in the 0.0 because it'll just take it off anyway. 12.5, 14, 17, and 20. All right, give you a sec just to get caught up with me there. All right. So once we have all of our data in, okay, then we want to tell Google Sheets what stuff we want to put on the graph. Okay. In order to do that, you just highlight. Okay. Make it all turn blue like it did for me there. Okay. So you just put your arrow in the first box, click and drag until you've highlighted everything. Okay. So watch again here, guys. Just put your arrow in the first box, click it, and then highlight everything. Okay. Click and drag, highlight everything. Once you've done that, then you're going to go up to Insert. Okay? And then it's going to give you some options. Okay? We're going to go straight down here to Chart. And when you click on that, this other dialog box comes up. Okay? Now that we don't need that other stuff, I'm just going to maximize here so you can see it a bit bigger. Now, I don't want anything from this first Start menu because there's nothing good there. Okay? I want to go over here to Charts. Okay, so click on the Charts heading, and you're going to see it gives you these options. Now, it says line, and we want a line graph, except that their line graphs are not the right kind of line graphs. So we're going down here to Scatter. And essentially, every time you do this in physics or in Science 10, you're going to use a scatter plot. All right, so we click on Scatter, and it gives us these two options here. We want the top one, Scatter Chart, okay, not Bubble Chart, so we click on Scatter Chart. Okay. Yes, just physics. Okay, so we click on Scatter Charts, okay, and there's our data. All right, shows us the graph there. Now, is this graph got all the things on it it should? Okay, it doesn't yet. All right, so I can click on Chart Title here right now, and I can change that, okay, and I can make it, oh, sorry, no, I have to go to Customize, sorry, to do that. So go over here to Customize, okay, and it's going to give you all the things that you can change, like Chart Title. We don't want it to be Chart Title. We want it to be okay, something like that. I know I should probably capitalize all of those, but yeah. All right, so when you do that and click somewhere else, it renames your graph. Now your graph has a title. Okay, it was one of those things that we talked about yesterday. Now, for the legend, okay, the legend's probably fine the way we leave it. Okay, it's not going to hurt anything to have it that way. Background, you typically don't mess with. Okay, axis. All right, so you can see here if we scroll down a little ways, we get axis. And right now we're working with the horizontal axis. If you click the arrow, it asks you about the left vertical, which we'll do in a minute. All right, our left axis, or sorry, our horizontal axis should have a title, and that was the number of sheets. And we should put the units in there, sheets. All right, click anywhere else, okay, and it shows up down at the bottom. Okay, we want to do the same thing for the y-axis, which they call left vertical. So you click on that little triangle there, go to left vertical, and do the same thing, except this is going to be book thickness. And that was in millimeters. Okay, click anywhere else, and it puts it on there. Okay, everyone with me so far? All right, keep scrolling down. Okay, grid lines. Right now, there's only the major grid lines on there. If you want it to be really, really accurate, really busy, okay, you could put minor grid lines on there. All right, so it does it there for the horizontal axis, or for the left vertical. You do the same thing for the horizontal if you want more on there. Okay, it'll put more on and just looks so you got more grid lines. You don't have to do that if you don't want to. Okay, now if you keep going down here, okay, you'll see down at the bottom it says trend line. This is basically all the way to the bottom. Okay, you'll see trend line, and right now it says none. Okay, we want to change that. What kind of a relationship is this? It's linear. So we click on linear, draws a line for us. All right, now you'll notice your scroll bar moved up a little ways because as soon as you put a trend line on there, you get more options. Okay, and one of those options is the label. This is the thing you definitely want, because if you click on this, one of the labels is use equation, which basically means it's going to spit out y equals mx plus b, and it'll have filled in m, the slope, and b, the y-intercept, for you. So when you click on that, notice that over here now, you see your equation. Y equals 0.15 times x plus 5. All right, so they're telling us the slope of this line is 15 or 0.15 millimeters is the thickness of how many sheets? Okay, I just divided millimeters by sheets. So is this the number of millimeters for one sheet? Yeah. Okay, it just told me millimeters per sheet. That's the thickness in millimeters of one sheet, okay, in that book. All right, and obviously the y-intercept here is 5, all right, for us. Everyone with me on that one? All right, so this is really handy here because it saves you having to do rise over run and all that kind of stuff. It spits out the slope for you. It does all your work. Okay, everyone with me on that? Okay. Now, if you wanted to copy that into a Google Doc, okay, it's relatively straightforward. I'm just going to open up a Google Doc over here and show you how you do that. Okay, so now that I've got that open, okay, I'll go back to here and just put in, come on. And now it won't let me do it. Oh, nice. All right, sorry guys. That worked really well the last time I did it, like this morning, and now it's not working. Okay. Now, if you want to put that into your Google Doc, click Insert. Okay, so now you've got it here, all right, and then you've got options here. Quick Edit, okay, View Mode, and up here on this little triangle, okay, you can copy the chart. Okay, so you click on Copy, and then you go to your Google Doc, which is over here, and you click Paste, and in a second, it'll show up there after it thinks for a minute. Okay, and then it's in. And that's what you're going to do, guys. Whenever we do graphs, okay, you're going to insert it into your lab report in exactly that fashion. Okay? Now, sometimes we'll also want to insert the chart, okay, the chart itself. So right now I'm just going to, okay, move this over here out of the way. Okay, I've got this area here that I'll probably also want to copy. Okay? Right, and I want to put that, and sometimes this formats doesn't work very well, but okay, we'll just come down here a little ways. Whoops, and still copy that over. Don't want that. So once you have the graph on there, guys, if you want to copy this, you just have to click off so that it's not highlighted, and then you can re-highlight it, and then click Control-C. Okay, it'll copy over, or click and Edit Copy. Okay, and it'll copy it over to your Google Doc, and then you just paste it in over here, because we'll often want the chart in there as well. Okay, in your Google Doc when you hand it all in. So you'll have your chart and you'll have your graph. Just put them in the right places, and you're good to go. Okay, everybody with me so far? All right, now what we're going to do here is just close those up, and I'm going to show you how to do a graph where you will have more than one. Okay, where you're going to have more than one set of data. So you're going to have essentially more than one line on your graph. So let's say you're running the same experiment with 3 or 4 subjects, which is what we're going to do with these carts here in a few minutes. All right, so we make a new Google Sheet. Okay, and this one we'll just call Trial 1 or something. I'll call it Trial 3 because I think I have 3 files in there already called Trial. Okay, and I'm just going to put up in here time in seconds because this will be like what we're going to do. Whoops, not big M, little m. Okay, and I'll just make that so that it's wide enough to include it and not have a 0 in it. Okay, click in here, make this one a little bit wider as well. Okay, and we'll just call it cart 2. Position, that'll be in meters. Okay, and we'll just do a third one here, just to have 3. Okay. Okay, so now we'll just fill in some fake times here. Let's go 0, 1, 2, 3, 4, and 5. Let's go up to 5 just so we can do it quick. Okay, so for cart 1, we'll make its positions pretty much the same. 0, 1, 2, 3, 4, and 5. Okay, for cart 2, we'll make it 0, 2, 4, 6, 8, and 10. And cart 3, we'll make 0, 3, 6, 9, 12, and 15. All right, so now we've got 3 different sets of data. Everything else is the same. Okay, we don't do anything else different. I click on the whole thing, highlight it all, go to Insert, go down to Chart, just like I did before. Okay, click on Charts. Okay, go to Scatter, because that's what I want. Scatter, boom. All 3 sets of data show up on the graph. Okay. And then we go to Customize, right? And we do all the same things we did before. We change the chart's title. Okay, so the chart's title is going to be position versus time for carts or something like that. Okay, you don't necessarily have to be doing this along with me, guys, just as long as you're watching. Okay, all right, and then we'll do same thing here, horizontal axis. Okay, we'll call that time, and that's in seconds. And then we'll do the same thing, left vertical. Okay, we'll make position in meters. Okay, and then you can fool around with the grid lines if you want. We'll just skip that for now. Okay, so now it's given you here because it knows you have 3 different series or sets of data. It's got them all in here separately. That's what we want, because we don't want it to do one trend line for all 3 of them. We want it to do a trend line for each one. Okay, so now we go down here and we go to trend line. This is linear, so I click on linear. It draws the trend line for cart 3. Okay, and then I tell it that I want, okay, all those same things that I had before, like the equation, okay, for its line. Then I go up and do the same thing for cart 2. Okay, trend line is linear, and I want the equation on there. It'll draw it in. Same thing for cart 3. Okay, I want the trend line, and I want the equation for it. Boom. Now they're all on there. Okay, and I've got 3 sets of data. I know it seems like I'm going really fast, but it's because I've done this a bunch of times already. Okay, trust me, once you've done this a few times, your graphing is going to be that fast, and that's the whole reason why we're doing this. When we used to do this lab with graphs made by hand, it was 2.5 days, okay, worth of work, because people had to measure and they had to draw the line with a ruler, and it sucked. Okay, this is what computers are for, to save you time. So this is the way we're going to do all of our graphs, okay, because it's just a lot easier. All right, everybody with me on how that works? Everyone's good with that? Okay. So guys, I'm going to put up another data set here, and I want you guys to fill in this same data, okay, and then practice getting graphs and best fit lines for it all here. Okay, so we're going to say we're going to make the manipulated variable time in weeks, and we're going to make the responding variable mass in kilograms. All right, so that'll be our data, okay, there that I want you guys to graph, okay, to practice graphing. Remember, okay, how you do that, you highlight it all, insert, okay, and do all that. I'll give you a couple minutes and then show you what mine looks like.
Zane Dixon, Aaron DeSpiritu, and Ryan